In this lecture, we're going to learn about the STD transform algorithm. And this is an algorithm that can take a transformation and apply that to each element in our collection. Here we have a bunch of examples. So we have our input data, which is going to be the input vector, and we have our output collection, and we want to apply a transformation to the input collection and put output in our output collection here. This is something we can do. So we can say STD transform. We're going to specify the input range, and that's going to be our input collection. We specify the beginning iterator and the end iterator. And then we're going to specify where we're going to be writing the output of this transformation. We're going to write the output starting at the beginning iterator of our output collection, which is this little guy here. And then we're going to specify which transformation we want to do in place. We're going to specify our predicate, which is going to say that we want to multiply each element by 2 and then store the value in our output collection here. And if we do that by specifying our output iterator like this, we're going to see that this is going to modify the data in our destination collection, but this is not going to extend it to take into account more elements that we are getting from our input collection here. You see, we are looping through a collection that has almost 10 elements. You can count this, but in our destination, we only have 3 elements. And what is going to happen, we're going to take the first one, the second one, and the third one. We're going to multiply them by 2 as per this predicate here. And we're going to have 10, 14, and 18, our destination collection. And that's going to be it. The collection is not going to be expanded to take into account more elements that we have in our input collection here. If you want the destination collection to expand and take into account all crazy things that are coming from the input collection, you have no choice but to use the back inserter mechanism. And this is going to give us an iterator that we can use to insert more things into our output collection. And if we do something like we have here, this is going to even add more elements coming from the input collection. And this is going to work really well. This is how you can use the transform algorithm to transform data in place. You can really do all kinds of crazy things with this. And if you want more information, please come to CPP reference here. You're going to find the requirements on all these parameters here, and you're going to know the return value. You're going to learn about the complexity of this algorithm. You're going to learn about all kinds of crazy things. If you go down, you're going to find even more examples you can play with. So this is a good place to come if you want to learn about these things here. For now, I am going to go to Visual Studio Code and play with us a little more. Here we are in our working folder. The current project is transform. We want to learn about the STD transform algorithm. We are going to grab our template files and put them in place. Let's do this. And let's crack this open in Visual Studio Code by dragging and dropping here. We will have our main CPP file that we can now clean up and close the sidebar here. We can include our algorithm header because we need that. And we will need the vector class, so let's put this in as well. Let's put in our print collection function, which is going to print collections as we modify them to see if our modifications are actually doing anything useful. And we will put in the code to play with the STD transform algorithm. In this case, we're going to be passing in the range for our input collection, and we will specify the destination iterator where we want to start pasting from. So that's going to be the beginning of the output iterator because we want to override anything in there. And then we're going to specify our predicate that we have here as a lambda function. So this predicate is going to go through the input. It is going to take each value in our input collection and it is going to multiply that by 2. And the result of this is going to be plugged into our output collection. This is how this algorithm is going to work. Now, one thing I want you to see is that if you specify the location where you want to paste in our output collection using the syntax here or using a direct iterator, this is not going to expand if we happen to want to plug in more elements than can actually fit in the current container as it is. So you see, for example, that our size is 3. So if we try and put in more elements, we would need to expand this collection. But if we do things this way, the collection is not going to expand. We're going to see that the data is going to be pasted into the current range of elements that we have here, if I can say it like that. To prove this, we're going to print the size and capacity information before and after we do our transform, and we're going to see how these things behave. We can pass our code through the compiler. The build is good, so we can bring up a terminal window, and we're going to clear now and run Rooster. We are going to see that our output size is 3, the capacity is 3, and we have an output size of 3 and an output capacity of 3. So the container didn't expand, even if it is a vector which has the capacity to expand. And we have pasted data into our output collection. You see that here. And the data is doubles of what we had in our input iterator. So we basically grabbed the first 3 elements from our input collection, we doubled them, and then the result of that was stored in our output collection here. You see we have 10, which is double of 5, we have 14 and 18, and this is what we get by multiplying what we have in the input collection by 2. This is going to work. Let's make sure we didn't get any kind of crash, because these things are really dangerous. You should be careful. So let's stdc out and see if we hit the end of our C++ program. This is a good way to test and see if you didn't get any crashes in your program, especially if you are doing something like this that has the potential to try and use more memory that is currently available in your collection. Let's pass this through the compiler. The build is good, so we can clear and run Rooster, and we will see that our program will run all the way to the end and everything is fine. But this is not something I recommend, because this is really going to ignore many elements that you would like to put in your output collection. And a good way to do this is to use the back inserter iterator that you get by specifying your output collection beginning iterator like this. You say std back inserter, and this is going to return an iterator that you can use to insert more things into the collection. Let's pass this through the compiler to really show you the result of this. The build is good, so we can clear and run Rooster, and now you see that our output collection has grabbed everything from the input collection by doubling the data. And we didn't override the data that we had in our collection, which is pretty cool. So we have the original data, and after the original data, we started putting data that we got by applying our transformation to the input collection here. So we have 10, 14, 8, all the way to the end element, which is 46. And you see that 46 is 23 multiplied by 2. And this is working exactly as we want. You see that we have even adjusted the size and the capacity for our output container. And this is something you can achieve by using the std back inserter facility, which is going to give you an iterator that you can use to add more things to the output collection in our C++ program here. As usual, if you want to learn more, you can come to the documentation. You're going to find our transform algorithm. You're going to see all things that it expects. You can learn about the parameters. You can even look at a few examples of how you can play with us. This is a good place to come and learn more about these algorithms from the STL. We are going to stop here in this lecture. In the next one, we are going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.